Hello and welcome to our third part of The Farmer Was Replaced. Leaving off in part two was mostly a refactoring attempt, and then we did our first pass at pumpkins, but we haven't made them super efficient yet. Before we kind of get into that, I do want to make sure I kind of step through the system that we're starting to build, just in case we didn't watch part two. Our main module we're keeping pretty simple. This will just kind of handle a lot of the little bits of, I call it runner code. It'll basically just hand things off to other modules. So we have our simple while true, and then we're going to call a traverse plot function, which we'll pull up in just a moment. We're going to pass in one of these actions, and then I have a variable that I hate, so we're probably going to rename it or rework it some point very, very soon. Loop check is a horribly undescriptive variable name. And then this basically is just our first pass at pumpkins. We can see why this first pass isn't so great if we move into our actions, our plot, which would be this traverse plot function. We'll notice that everything is just looping over the entire plot. We haven't built any other kind of traversal. We don't have any point to point. We don't have any find the nearest point and go there. We don't have any of that built in yet. So that's going to be one of our top priorities for this episode. We'll also notice that traverse plot will take in some sort of action. So it'll arrive at a cell and then it'll call this action. So if you look at the different actions we have an action for trees and carrots. We also have pumpkins, which is the one that was called here. Basically, we're just going to plant until we can plant no more. Our last one here is going to be this farming, which is going to handle most of our planting kind of logic here. We only have one function, and it's doing a bit more than maybe it needs to. We have this plant, till, and water, which will take our entity to plant, a variable on whether or not we want to water, a minimum and a maximum threshold for watering. And then we also added some kind of parameter validation to make sure we don't end up in an infinite loop as we're trying to water. And so that is our current state of the code. Now, as I mentioned, our pumpkins are horribly inefficient right now. So we need to build in some new features into our plot. And I don't know why I'm moving these modules around so much. Our development is going to start with this plot here. Okay, so what we really need to do here is we need to come up with a way to go point to point. I'm going to think a little bit about how I want to do this. I do want to keep the possibility open for sorting by nearest points, but I don't necessarily want to get too distracted. I want to do very incremental changes here. So I think for now, we're just going to take in a list of points and we're going to each point in series within the list. So that's enough of me talking. Let's go ahead and write a new function and let's figure out what to name it. Hardest thing to do in programming is coming up with a good name. We'll call it traverse points or coordinates. And we're just going to take a coordinates list as an argument. Now, we're going to do a simple list for coordinates in coordinate list. And then actually, I'm going to add a quick comment here as a little to-do. Okay, so I got a little antsy. We haven't actually made our move by point functions yet. So that's also going to be in our plot because plot is handling any sort of traversal and things like that. So what I'm going to do is we're going to create two functions. So first is going to be move to coordinate, and then it'll be x coord or x val, y val. And then from here, we're going to just say pass as a placeholder, and then our next function is going to be the main. Well, let me back up. So if we just have this one move to coordinate point, we're going to have to basically perform the same logic for x and y, regardless. It's going to be repetitive. Instead of writing the same thing twice, I'm actually going to break it out into a separate function, and we're going to call it move on axis. So we're going to take our start point, to point. I'm going to call this from point to point. So from point to point. And so since we're in one direction, we don't necessarily know which direction we're in. We could do this two ways. We could give some sort of value for is x direction as a Boolean, which I'm actually somewhat tempted to do. I guess I'll draft out the two options. So we could do is x direction and just default it to true or something. I don't like defaulting this. Let me actually just break it up into a comment. Okay, so here's kind of the two options. I'm leaving it all in comments for now. This option one is kind of what I was thinking about doing before, where we take our from point, our to point, our positive direction, and a negative direction. And then if I'm going to spell it negative, I should spell it positive as well. And then this way, since we don't inherently know which axis we're moving on, or we don't inherently know which direction to call when we call our move. So if we provide our positive and our negative direction, then we can basically say like, all right, we're starting at this point, we're going to this point. Here's what positive means, here's what negative means. And then when the, small little algorithm figures out we need to go +2 to get there, it can call the positive direction twice. The alternative is we can say is X direction. We could just as easily do the Y direction. And then we could almost remove our from point. And instead of direction, I'll say axis. I think I like this better. It's fewer arguments, less to manage, and we'll just manage it within the function instead of passing a bunch of extra arguments in. So yeah, we're going to do this. So we have our function for move on axis. I guess here's one other area where I find myself struggling a bit weirdly in the game, and it's been pointed out in the comments, I believe, of the last episode, where I am quite comfortable with Python. Like, it's a language I write in fairly commonly at work. Not knowing what this game supports in terms of Python functionality trips me up a lot. Because what I would normally like to say would be like positive direction equals this is better to do like east if is x-axis else west, right? But if I click off here, it's gonna not like the fact that there's this if statement here. So what I will do is I'll just east equals west, and then we'll do if not. Like, it's not a very Pythonic way to do this, and so we'll do if we're not on the x-axis, and we'll just update this to north, and if I could spell north, oh my god, and then our negative direction equals south. Okay, so we have our directions figured out, and then I guess actually one more thing to maybe explain here. Python is very weird about variable scoping. Generally speaking, in other languages, like think Java, C#, with very strictly defined scopes, if you define something within an if statement, it won't be accessible outside of that if statement. Like, its scope is limited to the if, so that's why I'm kind of in this habit of defining things outside of the if statement, despite the fact that I'm pretty sure with Python, if I defined it in an if-else statement, it would kind of still exist. All right, we have one more thing to do here, and I don't need a second set of if statements to do it. From point equals get position x, because remember we're starting with the assumption that we're on the x, like the x point, and then if we're actually on the y point, then we'll recalculate it. Equals get position y, and that should be equals. Okay, so we have our starting points all figured out here. Now we have a little bit of math to do to determine the best way to move and how much to move. Okay, so to calculate how much we have to move, we can do a pretty simple. We have our to point minus our from point. And I should actually really assign that to something. That'd be nice. Move amount. That's a positive distance. Is going to be our to point minus our from point. So if we're moving from position, or like point 1 to point 4, 4 minus 1 is going to be 3. We need to move positive 3 times. So we have one more check to make here. And actually, I'm going to do this. So I want to handle any cases where a point we're given is not within the world size, right? So if we say we have points 0, 1, 2, and 3 on our current plot, and we get passed in move to x coordinate 5, I want to be able to keep that on the world scale. It'll also be very important for making sure that we've arrived at our destination. So I'm going to do this modulus gets world size. Similarly, if we get like -2, we should be able to place that on a specific point within our plot using this modulus. I don't think that makes sense. Hang on. I put that in the wrong spot. One more thing in our little setup here. To point equals to point modulus get world size. And what I would like this to do basically is if we get that -2 value or like a 0, if we say we want to move to x position 7 or x position -2, I want to be able to put that on a specific point within our plot. If we need to move +4 spots, this function is happy to do it regardless of whether or not it will eventually wrap around. Remember, our from point is calculated, so we don't have to worry about it there. It's always going to give us a point on the plot. So we have our move distance. Now we want to check if it's faster to move in the negative or positive directions. So what I'm going to do here is if move dist is greater than move dist modulus, and then this will be open paren gets world size. That'll be a function call over 2. Hey, so it's me from the future. It's editing me. And I just got to this part, and I am stumped as to how I thought this made any sense at all. And if you can see, I'm on the GitHub for the part 3 branch here, which means I didn't catch it in this episode. Normally, I catch these at some point, either when it throws an error or when I, just happen to notice that I've been stupid. But this was an undetected amount of stupid. There's no reason to do a modulus here. It's just if the move distance is greater than half the world size, go the other way. And some bad news bears. I have maybe already recorded episode 4 and clearly did not notice this. So I'm going to create a GitHub issue and we're going to resolve it probably in the beginning of episode 5. So sorry about that one. Anywho, I guess back to our regularly scheduled programming. That joke just made it worse. Before we begin this if statement, we want to default our move direction equals positive direction. So we're going to assume that we're moving the positive direction, but if it's less efficient to move the positive direction, change our move direction to the negative direction. Oh, and then, one more thing. This function is getting to be a little bit more than I want it to be, actually. So we have our move distance, and then what I'm going to say is our move increment. That'll be +1, and then our move increment, if we're going the negative direction, equals -1. So we're going to say while from point is not equal to 2 point, we're going to move in the move direction. And then we want to say our from point plus equals our move increment. And honestly, what I could do and what I may very well do, we could do another thing where we save a function. I think I have a better way to do this that'll actually use the game senses instead of relying on just me to keep track of the position. And we'll use the same callable idea again. So our position check function can be equal to get position x, but we're not going to call it this time. We're just storing the function, and then the same thing here. I'm just going to copy it. I'm going to paste it, and we'll change the x to a y. Now in our while loop, we can say while position check, and we can call it now, is not equal to our 2 point. And I didn't actually put the get position x there. And I keep hitting escape for some reason. I'm just going to add a couple of comments. I'll probably cut past this because it's boring. Okay, so we've added some comments. One thing I realized is I still had the move increment in there, which we no longer need. That allows us to create our move coordinate function, which will repeat this logic for both x and y. So our move to coordinates is going to be pretty simple. All we're going to do is move on axis. We're going to pass in our x val. And then I'm going to specify this is x-axis equals true. And then move on axis. Y val is x-axis equals false. Cool, awesome. And as simple as that was, I'm just going to, for no reason at all, add a return none to the end of these. So as easy as that, we have our move to coordinate function, and now we can continue our traverse coordinates. And one other thing we're going to need, very similar to our traverse plots, we're going to need our action, our callable to perform here. We have our coordinate in the coordinate list, and it's going to be a tuple of x and y. So we'll say move to coordinates. If I spelled that correct. Apparently I did not. Oh, I didn't spell it correctly down here. That's why. That's funny. So move to coordinate, and then we have our, you know what, I'm going to shorten this. Okay, I believe that's going to be correct. So we're going to move to the coordinate, we're going to call our action. Actually, we'll save the results. And I want to rename this action result. We'll do the same thing here. So for coordinate in our coordinate list, move to coordinate 0, coordinate 1, which will be our x and then our y. We'll call our action, we'll grab the results. We'll say if action result, and I'm hoping I'm spelling this correctly again, then result list append action result. And I am aware that I haven't actually defined result list yet. Ah, that's stupid. Okay, action result. Okay. And then very similarly, at the end of this, we're just going to return result list, and then I need to make this an empty list. I guess I forgot that step. Okay, so I'm thinking out loud here for a second. One of the things I was worried about is if we have the full grid, like if we're doing pumpkins and our first pass, we're going to obviously plant something on every square, which means we need to check every square the next time. And I wanted to build in some sort of short circuit where if the whole grid needs to be done, we'll just call traverse grid instead. However, the order things are going to be put in the list here means that they're going to be put in the list in the order that they were planted the first time around. So effectively, if we plant the whole grid, we're going to be calling traverse list anyway. We're just going to be moving one point. And then we'll just be skipping over any points that we didn't plant in subsequent times. So I think this is actually, we don't need to touch this. I think this is good to go. It might be a bit ambitious to assume that this is all going to run on the first try, but I don't see why it wouldn't, at least not yet. I'm sure I'll eat those words in a second. What do you not like here? Expected a comma or a closing bracket? Okay, I guess it doesn't like me naming the variable that I'm passing in, so that's fine. So we have our planted coordinates. Basically, all of this is actually going to be very much the same. Now, we do need one thing. So I am admittedly jumping around all over the place here. Okay, the loop check was really bothering me, so I renamed it to continue planting. So we're not going to use traverse plot anymore. What I'm going to do, actually, is I'm going to define a constant of full plot equals... I'm thinking, instead of doing this full plot nonsense, we're actually going to go back to that idea of if, checking if we need to plant the full grid effectively. It'll be kind of a mix of both. So we don't need full plot, and I am definitely overthinking parts of this, but if we want to planted chords sort of as an empty list, and then continue planting equals true. Now what we'll do is if not planted chords, then we'll do plot.traverse plot for our first round, and our actions will be actions.pumpkins. Else, could probably actually switch this. Continue planting, we'll check that after everything's done. And then same thing here in our else statement, planted chords equals plot.traverse plot pumpkins. We are running low on other materials. We have plenty of pumpkins, we have very few carrots, very little hay. So what I'm going to do is start kind of saving some of this stuff into functions within our main function for now. This is definitely going to move. So we're going to call this a run pumpkins function. And then we're going to make a similar def run hay carrots wood. And honestly, I could probably go into the Git repository and just grab some of our old code out of here, but where's the fun in that? So for now, we just have to rebuild our old action here, which could be traverse plot, and we'll call it. We have trees and carrots. I don't really want that. So we're going to make a new action off of trees and carrots. And the only difference between our existing trees and carrots is that we just want to split non-tree items between carrots. And yeah, this kind of goes back to the first thing we did of we'll plant trees wherever we can, and then we'll split the world size in two, and anything on the top half we'll plant one thing, and on the bottom half we'll do something else. And now we get to a point where we might want to add something else to farming, because I don't think we really have anything for hay here, do we? Okay, yeah, so for hay, we haven't really built that into our plant till and water. So what I'll do... Actually, let's do one more thing, because we can clean some of this up. We've got like random lists kind of scattered around. So let me do no plant entity is she's not grass. The idea here is we're just building some constants, which means that these should be all caps. Let's see, soil. Let's see, we'll do grounds, grass, plants, equals. So far, I think pumpkin, carrot, I mean, bushes and trees can grow wherever. So I think we're going to start looking at saving our till operations a little bit. Not in... And the name of this particular variable isn't that great. But the idea is we're making a constant for easier reference later if we want to reference it somewhere else. Ground's not grassland. And then if it's not in our grass, I'll just expand this to grassland. That makes a bit more sense. And then instead of plants, we call this entities. If I could freaking spell. And then instead of grounds, we can just make this grassland entities, because that's the name of the ground. That's a better variable name. I like that better. Or something else. Okay, cool. And then basically what we'll do is if entity not in... This is overkill. This is no plant entities is only ever going to be grass. Nothing else just does that. So there's no point. If entity not equal entities not grass. So the next thing is that I did mention that we only want to till where it's required for the plant. So we'll say like entities dot bush will also be in this grassland entities as well as entities dot tree. I honestly don't remember pumpkins, but I do believe we're going to want to till for that. Okay, I think that's good. I think we've kind of solved that up a little bit. We're not going to plant if there's nothing to plant, right? You can't call plant entities dot grass. Okay, so now this plant till and water should handle everything here. Should handle everything we need it to. It should be decently well updated for what we're doing. It doesn't like something over here. Never mind, that's a me being stupid problem. When I copied and pasted, I brought the function definition in. Okay, so now that we've fixed up our planting thing, we can actually finish our idea over here in actions. And then I'm gonna, before I do that, I'm gonna clean up my coding windows because they've become a mess. Okay, we've cleaned up the windows a little bit. It should be a little bit nicer. And now our last little else here is gonna be farming.plant till and water. We're gonna say entities dot grass, and I don't want to water grass. Granted, I mean, we have so much water because I do take my time here. And then I'll just add a return none to signify the end of the function. I'll do the same up here at the top. I don't think there's anything I've forgotten, but there's only ever one way to find out. So let's give our main our final touch-ups, and then we can start running. Coming back to this, well, basically we completely copied and pasted our main function, our original main function, and we actually defined functions within our main module. So we have our pumpkins one, which is what we were just working on. We have our hay, carrots, and wood, which is our new one. So this current action doesn't actually require anything. It's basically just a while true, and there's no traversing of coordinates here. It's just, plant things. And we're always going to continue doing that. Our action is going to handle everything else. So our action takes care of everything, whereas pumpkins, we have a bit of extra logic because we have to do things based on the result of each round, which is going to kind of play into why these are separate functions and what this is all going to build, and what this is all going to build into eventually, which is kind of this idea of routines on top of actions. As we get into leaderboard or like speed run or timed run kind of stuff, I think that'll be a lot more important. Tangents and more tangents. So we're going to call, so for actions.pumpkins, we're going to say actions.haywoodcarrot. I don't really like that name, but it's fine. I wonder if it'll let me do this. If name looks like it equals main run hay, carrots, and wood. And so this will call our runner function here, which will just run our action. Actually, we don't need that anymore. We have a better hay, carrot, and wood. And somewhat expected, we have an error because I haven't called a function because go me. We have another error. Return plant stat. Ah, okay. So we'll actually define it because we went into this if statement. We never defined plant status. We'll just define it as none. If we don't enter this if statement, then it'll just stay as a none. Or I mean, we could just make it false, but I don't want to do that. I think none is better. Now we'll try one more time and see what other fun errors I've made along the way. So far, we're looking pretty good. Okay. Oh, I think I get it. So I made one small logical error here, and that is the get world size divided by 2 returned 2, and so I said if it's greater than 2. So if y position, or it is divided by 2 minus 1. And order of operations will take care of this, divided by 2. Or I'm fairly simply, we can just say greater than or equal to, and then I think that'll handle everything we needed to handle. Because the only corner case here is if we have 5, it'll divide to 2.5, and if 2 is greater than 2.5, greater than or equal to 2.5, which it is not. Yeah, I mean, if we have an odd number of rows or columns, an odd number world size, we're going to run into a spot where it has to pick a side anyway, so I think this is fine. That being said, I think that should, I mean, everything works. I just didn't think through that divide by 2 very well. So we're running, we're planting and watering. It looks like from that last round, we still had some things that were already watered because I don't think clear really overrides the water level of a cell. Cool, and we're getting some stuff quite nicely. Okay, so we've, at the very least, we've accomplished our goal here of getting some more resources. I think here's the rough plan. We haven't gotten to see the improved pumpkin logic. We haven't tried our new traverse coordinates function. I'm going to start with the run pumpkins. With our run pumpkins function here, we'll get to see our new pumpkin logic. And then I think we're going to start sunflowers. But for now, I do want to see the improved pumpkin logic running. So we're going to go ahead and give this a run on our new run pumpkins kind of runner here. And then, of course, right, okay, I misspelled this. That's embarrassing. If not is x-axis, then this. Okay. Well, that's tragic. Not really. Just makes me feel bad about myself. I will go ahead and try that again. I think we fixed it. And, I mean, honestly, we're still getting water faster than we can use it. Did I misspell? Okay, so we also have another issue from point. Okay, I'm hoping this is good. Boy, our plot thing is having a whole bunch of issues here. Oh, okay, so yeah, one more problem here. I literally just respelled from point and realized that when we moved away from tracking our own position, I never actually updated this from point. So we don't want from point, especially now that it's not a parameter. Remove distance. We're really just using this to calculate distance. We can do our get, our position check function. We'll call it. We'll see. Go ahead and minimize that, and I think just check one more time because this plot has been giving me a bunch of problems. Now we're coming to the end here, and this is where I think we'll see if we have an issue. Okay, we have one problematic one. It should just go to these two. Awesome. I'm not totally sure how thrilled I am with that. That seems a little bit weird. Oh, because we never actually moved our way back to the origin. I mean, do we need to move back to the origin? It feels like it kind of keeps track of it. Awesome, and we have some pretty decently improved little pumpkins. Sweet. So I'm just going to honestly let these pumpkins run for a little bit, and then we'll be able to unlock some more stuff. But I think next on our list here is going to be sunflowers. All right, and welcome back. We haven't gathered too many materials, but we do have, I think, enough to start moving on for now. Also, it is a new day, so good morning. Got some coffee starting to flow. Next, I think we're long overdue for an expansion. This is pretty cheap. Also, I do want to get started on, I think, sunflowers. We do need a little bit more carrots, so maybe we'll run our hay, wood, and carrot system for just a little bit. I believe we already have our run hay, carrots, and wood. For the remainder of this part, I know last time I did spend... Oops, we're running pumpkins. My apologies. You know what? Let's just see what an 8x8 pumpkin looks like. Correction, 6x6. Do we just want to do 8x8? I feel like 8x8 could be fun. You know what? I'm going to do it. I'm going to let this pumpkin finish, and then we'll do it. I mean, there's a few things here that will definitely be improving later. For now, I'm happy enough with it. What was I going to do? Oh, the expansion. We're going to just go to 8x8. Perfect. If we want to see, do we want to do an 8x8 pumpkin just because? Let's enjoy our handiwork for a second. I think 8x8 is starting to look pretty rewarding. I probably should have gone for expansion earlier, but also I realized I haven't gotten fertilizer at the end, and I'll probably cut most of it out. Like I said, I don't want to focus everything on these little refactors. It seems kind of not ideal, but okay, so we have that. That was a lot of pumpkins, actually. Before we get too far distracted, time to stop the run pumpkins. And we're going to switch over to our hay, carrots, and wood. Okay, so we are at a point where we can unlock our sunflowers. So we're going to stop this, go into our unlock tree, unlock sunflowers. Okay, sunflowers collect the power of the sun. You can harvest that power. Harvesting a grown sunflower yields power. If there's at least 10 sunflowers on the farm, you have to harvest the one with the highest number of petals. You get 8 times more power. If you harvest a sunflower while there is another sunflower with more petals, the next sunflower you will harvest also only give you the normal amount of power, not the 8 times bonus. So let me just draft this out here in some comments. I feel like dictionaries are just the nicer way to do this. This works, and it is a way to do it without dictionaries, but we just need a little bit more pumpkins, and then we'll be good to go. Yeah, I mean, we have plenty. We just have one more dead pumpkin left. All right, and we're going to go ahead and stop it because we don't have enough for this run. So we're going to go back to just our, run a bunch of things. Hay, carrots, and wood. Oh, we're going to let this run for a little bit. Okay, to speed some things up, I'm going to just make a hay and carrots thing. I think we're doing plenty fine on wood, so I don't need to run a tree grid every single time. So just make a hay and carrots thing, and I'm also just going to tidy this up a little bit. Oh my god, we finally used all of our water. That's crazy. We are back up to 400 carrots. I do kind of want to do some quality of life improvements over here, so we are going to improve our carrots. This is mostly just to reduce my wait time while I'm just kind of gathering some stuff. And then we also have a speed increase for 500 carrots, which we can also afford, so we're going to go ahead and go for that. And then at 1,000 carrots, we can do that again. Okay, so while we're still gathering some resources, I think I am going to improve... So we're going to improve grass, we're going to improve speed. And then our speed is maxed out. Okay, I think we can go ahead and stop this now. We've gotten a fair bit of resources. We do need to switch back to pumpkins so we can unlock the things that we want to unlock. So I've gone back and forth on this one about 20 times by now, but I am going to add a should water parameter here, which means I need to add parameters to all of these. Param. If I don't have a use for a parameter, I'm just going to say param should water is... Okay, so we're going to do 2 things. Should water, basically, we're not going to water everything because we have such a large plot to get to, but when we start getting to, let's say like under 10 squares or something worth of pumpkins, instead of sitting there and doing a flip and waiting for everything to grow all the time, that's when we're going to start considering watering. And then instead of false, we're just going to pass in should water. And then we're also seeing a glaring issue in our farming piece. While get water less than water 2. Okay, so then we want to say and num items dot water greater than 0. And all this time I've been worrying about pumpkins. We have way more than we need. So let's go ahead here. Dictionaries, utilities. Let's do utilities. Back on topic, we were gonna do sunflowers, and now for sunflowers, first thing we need to do is create an action for plant sunflowers, because planting sunflowers is going to be entirely separate than actually evaluating and then harvesting them. So plant sunflowers very simply. I think these can be planted on any soil type. Correction, it looks like it works exactly like carrots or pumpkins. So actually, I'm going to add one thing. Clear harvest. We're going to write our own clear function. So we're just going to call traverse plot harvest. We're going to pass in the harvest function. So we're going to go to everything. We're going to harvest whatever's on a square. And then at the end, we're going to just call it regular clear. Okay, we're going to go clear harvest, and then, oh, harvest does not accept a parameter. Let's call this param. Okay. There we go. There we go. Okay, cool. Now we actually have to stop delaying and write our dang sunflowers logic. Working on our sunflowers, we have plant sunflowers. It has an action, which is going to be quite simply farming dot plant till and water. Check here. Okay, so then our return for this one is going to be different. So a parameter that we're going to pass into this is going to be unused because we don't need an actual. We don't need anything really, but it's going to be entities dot sunflower. We do not need to water these. If for some reason we can't plant somewhere, we can skip over it, I suppose. So if we've planted, then the plant measure, we're going to return a tuple measure, and then a tuple of the get position x and get position y. And then I think that's really all we need to worry about. So that'll plant something everywhere, it'll save measure, and it'll return a tuple. Okay, back to main. Now when I run sunflowers, we're going to do sunflower as a details equals plot.traverse plot, because we just want to plant everywhere. All we're going to pass in is actions.plant sunflowers. That'll give us all of our return information. Then we need to organize sunflowers by... Okay, so we're going to organize sunflowers by measure for f in sunflower details. Then I'll make a sunflower dictionary, empty dictionary. A not so small part of me wants to just create this with 15 descending to 7 and then go about it that way. And honestly, I'm going to do that. First we'll do like empty. So we'll do for I in range. Actually, let's do this. From 7 to 15, I believe we have 9 possible indexes. And so trying to iterate from 7 to 15 and then reverse it seems to make not a lot of sense to me. So I'm going to do for I in range 9. Oops. Sunflower dict I is equal to an empty list. And then that should, oh, correction, we'll do 15 minus I. So what this will start, it'll start at 0, be 15 minus 0 is the key, so it'll start at 15. And then this will basically just make a dictionary with keys 15, 14, 13, 12, 11, 10, 9, 8, 7. Frankly, I'm just going to put this into the thing. So this will create our empty, oh my god. Okay, we're just going to loop through the dictionary keys, which should already be sorted for us because of how we're preparing this dictionary. So then if we go here, actually we might have a, yeah, we're going to have a pass by reference issue here because I don't have the dot copy. So, you know, after all of that, we're just going to, and that should create all the keys in the order that we need them. Now, for sunflower and our sunflower details, our sunflower dict of SF0, which will be our measure, dot append SF1. So that'll add the coordinate to the appropriate dictionary key. Once we've done that, we'll do for measure val in, because we know the keys. So our coordinates list is going to be sunflower dictionary 15 minus I. We'll say plot.traverse coordinates. Our list of coordinates will be this. Our action is going to be to harvest everything. Harvest only. And I believe That should be good. Okay, there's no point to doing our clear and harvest, so we're going to comment that out. Down here, we're just going to call run sunflowers, and let's see how this goes. All right, we have an achievement for sunflowers, which popped off screen, just because I have this all in windowed mode for recording purposes. And we have an error. Okay, one more thing. While we're here, I'm actually going to rename this to sunflower results and sunflower dictionary grouped sunflower dict. Okay, I think that should be good. All right, we have everything planted, and we have another error. I used freaking parentheses instead of square brackets. And once again, we're coming up to the end of the plot. Let's see what our next error is. There it is, without fail. This is painful. Plant measure, plant measure. Yeah, that's rough, buddy. Oh, look how fast that is. That's so cool. Okay, so I never actually wrapped that in a while true loop, but that's cool. Let's actually define a main. And then this will be while true run sunflowers. So every time we do that, we're getting like 400 energy. So we don't need to do sunflowers for too long, but I do kind of want to admire the handiwork here. Let's go ahead and do it one more time. Look at us freaking go. We're going so fast. Zooming. That point-to-point navigation seems to be working pretty well. And with those speed upgrades, I mean, you can really tell the difference. We are cooking with grease. Awesome. And I think that's kind of everything I set out to accomplish here in this part, and probably a fair bit more. Judging by how long I've been recording for this episode, between two different recording sessions, I think we're probably at the longest part so far. So please do let me know how you feel about the length of these episodes. If you want shorter bites with smaller bits of progress, please let me know. If you'd rather see skipping some of the code to just make more progress in less time, please also let me know. I would love to hear suggestions or what you guys want to see. Also, if there's anything outside of this game that you want to see, please do drop me a note in the comments. A lot of stuff I'm kind of toying with doing. I think it's just not a lot of time to record, so I'm trying to keep myself focused on kind of one project at a time for now. And I hope to see you in the next part. Thank you so much.